Welcome to the Actualization Terminal. Our objective is to convert amorphous waste carbon into structural, isotopically pure carbon-12 graphene. The plenum formalism re-indexes the material's structural data directly, achieving transmutation while avoiding the radiation created by high-energy physical collisions. Before we begin, verify your materials. You will need the Actualization Terminal, your raw waste sample, a substrate of pure carbon-12, and a lithium-nitrogen dopant cartridge. Warning tone. Use only isotopically pure carbon-12. Mixed carbon isotopes cause nuclear spin-bath decoherence, which will cause the process to fail. Flowing the dopant induces a synthetic gauge field. This creates a Berry curvature in the electron sea, locking atoms into a rigid framework. As interior nodes go dark and boundary edges activate, the electron sea locks into a topological insulator state. This stable hardware foundation ensures absolute information fidelity during the coming actualization shift. With the hardware interface secured, we can activate the terminal's internal geometry. Use the interface to initiate the 5-level fractal nesting sequence. This geometry acts as a spatial impedance matcher. It takes large terahertz wavelengths and compresses them into nanoscopic hotspots. Monitor the plasmonic energy density. At the 5th nesting level, the density reaches the threshold required to bridge microscale inputs and macroscale effects. This geometric compression allows the terminal to bypass the massive power requirements typically associated with material restructuring. Place your raw waste carbon directly into the center of the nano hotspot zone. The terminal processes the raw sample as a collection of quantized descriptors, distinct informational points mapped within the plenum. Engage the address field, or AMU. This isolates the specific informational signature of your waste sample from the surrounding environment. The display now shows a jagged 3D point cloud. The system has locked on to the exact coordinates of the target material in the rendering queue. Mapping the physical object as raw data is the mandatory prerequisite to rewriting its state. You are now ready to initiate the non-abelian gauge transformation. Keep the shift adiabatic. The transformation must remain slow and smooth to prevent the data from collapsing. As the transformation progresses, the energy debt is paid by the address field coupling to the Higgs sector. This keeps the thermal noise flat at 0, bypassing the need for physical collisions. Rushing this shift creates a rapid temperature spike and generates dangerous decay radiation. Maintain the current pace. The thermal camera shows uniform blues and greens. This confirms the adiabatic state is stable and no heat is being generated. Observe the chamber. As the descriptors update, the amorphous material ripples and realigns into a reflective geometric sheet. The matter has been re-indexed in the universe's rendering queue, resulting in a completed transformation with 0 waste. Run a Ramsey interferometry test on the new material to confirm its structural integrity. The test confirms a perfectly structured, isotopically pure sheet of carbon-12 graphene, successfully created from amorphous waste. This process utilizes the universe's underlying computational efficiency, while strictly obeying the second law of thermodynamics. Mastering the terminal allows you to move past the limitations of traditional chemical engineering. You have learned to navigate the system interface, to define and stabilize material states directly.